Alright, so today we're going to be going over motion on an inclined plane. So we're going to be using three equations here. Most notably, the equation to find acceleration on an incline being a g sine theta, in which we take sine theta of the incline and then multiply it by the acceleration of gravity to get the acceleration of an incline. And then we'd use the final velocity equation in which we're gonna have different variations of this where we're gonna have to solve for either like acceleration, delta s, or even initial velocity. So this equation comes very handy, and as well the acceleration equation, which is just delta v is over delta t. All right, so let's take a look at number 26. So we have a car is traveling at 30 meters per second, runs out of gas while traveling at a 10-degree slope. How far up the hill will it coast before rolling back down? So let's first draw an illustration here. So we have our slope, which let's say this is 10 degrees, even though it's probably not. But so the car is going to be traveling up here at 30 meters per second originally, and we know that at some point it's going to be at 0 meters per second. So let's write down what we know. So we know V initial is equal to 30 meters per second. V final is going to be equal to 0 meters per second. And we know the angle is 10 degrees, so in order to find acceleration, what we should do is plug that into g sine theta to find acceleration. So sine theta is going to be sine 10, which is 9.8 times sine 10, which is going to be 0.174. And if we multiply those out together, we're going to have that, and this is going to be negative 9.8. We're going to have the acceleration be negative 1.7 meters per second squared. So we know that the acceleration is negative 1.7 meters per second squared. And we want to find delta S. Delta S is going to be how far up the hill will it coast before it starts to roll back down. So we need to find delta S in which the car stops moving and then comes to a rest and starts rolling down. So let's use the velocity final equation. So it's going to be velocity final squared v initial squared plus 2a delta s. And if we plug in everything, we have vf is going to be 30 squared, or rather 0 squared. Vi is going to be 30 squared. 0 squared is equal to 30 squared plus 2 negative 1.7 and times delta s. And this is a plus. And if we do some calculations here, we're going to move 30 squared to the other side, which is going to be negative 900. And then 2 times negative 1.7 is going to be negative 3.4 times delta S. If we divide by negative 3.4 on both sides, we're going to get that delta S is equal to 900 divided by 3.4. And the negative signs cancel out because it can be positive. Delta S is going to be equal to 265 meters. And that is going to be your answer for how far up the hill will it coast before it starts to roll down at a 10-degree slope. So let's move on to number 27. So a skier is gliding down along at 3 meters per second at a horizontal frictionless snow, and he suddenly starts going down the 10-degree incline. His speed at the bottom is 15 meters per second. So let's kind of draw another picture here. So that is kind of what it's going to look like. He's going to be coming here at 3 meters per second. And then when he reaches the bottom, he's going to be at 15 meters per second at a 10-degree incline. So let's write down what we know again. So we know that VI is going to be equal to V initial is going to be equal to 3 meters per second. V final is going to be equal to 15 meters per second. Acceleration is going to be, we're going to use G sine theta again. So it's going to be sine 10, which is going to be 0.17 times 9.8. which is going to give you the same acceleration, which is 1.7 meters per second squared. And this time it's going to be positive because we're starting at the top, this time the skier. And one thing to know as well with your calculator when you do this is you want to have it in degree mode because when you put in sine theta, you're putting in the degree in numbers between 0 to 90 or anything above that. When you put in numbers into a sine or trig functions with a degree, you want to put it in degree mode. So we have acceleration, and delta S is going to be, so for A, we're figuring out what is the length of the incline. Delta S, we don't know that. That's going to be kind of unknown. So again, let's use the v squared final function. So we're going to have 15 squared, which is going to be 225 on the right side, and then v initial squared, which is going to be 9 plus 2 times acceleration, which is 1.7, and times delta S. And if we do our figure this out, we're going to subtract 9 on both sides. That's going to be 216 is equal to 3.4 delta S, because 2 times 1.7 is going to be 3.4, and 216 divided by 3.4 is going to give us delta S of 64.5 meters, and that is the length of the incline. And number 2 is telling us how long does it take him to reach the bottom. So in order to find time, if you remember, the equation for acceleration is v final minus vi over delta time. So we know the acceleration. We kind of calculated that. We know v final and initial. So all we need to do now is just calculate that. So if we plug it in, we're going to have acceleration is going to be 1.7 is equal to v final, which is 15 minus v initial. So 15 minus 3, and then delta t. So we're going to have, we could switch the delta t and 1.7, in which it's going to be delta t is equal to 15 minus 3, or rather 12 over delta t, or not delta t, 1.7. So 12 over 1.7 is going to give us delta t of 7 seconds. It'd be 7.06 seconds, but we would round it to 7 seconds. So that would be how long it would take him to reach the bottom. Alright, so number 28 is as Santa loses his footing and slides down a frictionless slope, snowy roof that is tilted at an angle of 30 degrees. If Santa slides at 10 meters before reaching the end, what is his speed as he leaves the roof? So let's say the roof is kind of like that. So we know that's going to be 30 degrees, and Santa is standing on top of here, and he's losing his footing, which means we can only assume that he was originally standing, which means that he had no original velocity. So let's write down what we know. So v final is going to be unknown because that's what we're figuring out. What is his speed as he leaves the roof? V initial is going to be 0. And then delta S, we're actually given that here. That's going to be 10 meters before reaching the end. So his delta S is going to be 10 meters. And then the angle is going to be 30 degrees. So our acceleration is going to be again g sine theta. So sine 30 degrees is going to be 0.5. So 9.8 times 0.5, it's going to be 4.9 meters per second squared. And now all we need to do is just plug it all in into the original equation, or the velocity final equation. So v final squared is equal to v initial squared plus 2a delta s. And if we plug it in, we're going to have v final squared is equal to v initial squared, which is 0 squared, plus 2 acceleration, which is going to be, our acceleration is 4.9, times delta s, which is 10. And 2 times 4.9 is 9.8, times 10 is going to be 98, and that is equal to v final squared. Now if we square root both sides, we're going to have that v final is going to be equal to 9.8 meters, or 9.9 meters per second rather. 9.9 meters per second, yeah, just that's the velocity. So that is going to be a speed before he leaves the roof. Alright, so let's take a look at number 29. So a bicycle is coasting at 8 meters per second, comes to a 5 meter long and 1 meter high ramp. What is the bicycle's speed as it leaves the top of the ramp? So let's draw another illustration here. So let's say that's a flat plane that the bicycle is moving on, and then it comes up to a ramp which is 5 meters long and 1 meter high, and the bike is going to be uh, something like that. I don't know how to draw a bike, but it's going to be moving at 8 meters per second. And this is going to be similar to the previous questions. However, we have to find the acceleration, deceleration rather, from the ramp. And we're not given sine theta, or we're not given theta. So we have to figure out theta ourselves. So what law would give us, what law do we use the adjacent and the opposite of something? If you remember, opposite over adjacent, that directly correlates to tangent, or tan rather, the tan trig function. So what we could do to figure out theta, which is the angle of the ramp, and that'll help us find out the acceleration, is going to be plugging into a calculator tan -1, which would be arctan of 1 over 5, and then that would give us our degree. So if you plug it in tan -1 of 1 over 5, that would give you 11.3 degrees. And then so theta is equal to 11.3, and now we just plug into g sine theta, in which we just do 9.8 times g sine 11.3. So sine 11.3 is going to be 0.196, and then multiply that by 9.8, in which you're going to have that acceleration is equal to, and this is going to be negative 9.8, acceleration is equal to negative 1.92 meters per second. Okay, so now we could write down everything we know. So we know v v final, or we don't know v final, that's unknown to us. We know v initial squared, that's going to be, or v initial rather, that's just going to be 8 meters per second. We know acceleration, that's going to be negative 1.92 meters per second squared. And now we don't know delta S. Delta S now would be basically the length of the ramp. We can just figure out that using a squared plus b squared equals c squared. So a squared plus b squared equals c squared. We want to figure out this length right here. So we're going to have 5 squared plus 1 squared is equal to c squared. So that's going to be 25 plus 1 is equal to c squared. 26 is equal to c squared. So that means c is equal to square root of 26. So delta S is going to be square root of 26. So now if we plug it into the equation of v squared final equation, we're going to have, if we plug everything, we're going to have v final squared, which is what we're finding out here. V initial squared is going to be 64, which is 8 squared. And then that's going to be plus 2 times acceleration, which is negative 1.92, times delta S, which is square root of 26. And if you plug it in, you're going to have v final squared is equal to 64 minus 19.58. And then if you simplify the right side, you're going to have v squared final is going to be equal to 44 point, or 44, not 4.4, 44.1, or 419. And then that means V final, if you square both sides, it's going to be equal to 6.7 meters per second. So at the end of the ramp, as the bike leaves the top of the ramp, your velocity is going to be 6.7 meters per second.